Now I want to talk about another approach of segmentation, which is called thresholding. And what thresholding is basically just comparing the image with a function that is called threshold. And based on the result of that comparison, we can classify a pixel as belonging to the background or an object, a foreground. Okay, so let me give you a simple example to see what that is. So let's say that I have an image that contains some object like this one. Okay, and also let's assume that this object has values that tend to be darker. Okay, something like the gray color, and the background tend to be white, like for example this paper. Now, if I visualize the histogram of that image, I'm gonna see something interesting. So this is what I'm gonna get, something that would look like this. And this is the highest value that a pixel can take. It can be 255, but let's just say it's 1. So X here represents the intensity level. Density level. And the axis here represents the frequency N. And just to understand, just as a quick reminder of what a histogram is, it gives you a distribution of pixels. For example, let's say that for the pixel that has this intensity level, which is, for example, 0.1, I get N equal to 600. So what this means is that there are 600 pixels that have the intensity level 0.1. Okay, and of course the histogram is not continuous. It is in form of bins, something like that. Okay, and more the bins get thinner, more we tend to get something like smooth curve, something like that. Okay. Now there is one interesting thing that we can note here. We have a valley, and the reason why we have a valley is because we have two dominant objects or two dominant classes that are in contrast with each other in terms of intensity level. So the first dominant class is the object, and the second dominant class is the background. And this distribution here belongs to the object. Okay, and the reason, as I said, is just because the object tend to be darker, and this distribution is on the darker side of the intensity level because it takes smaller values. And this distribution here is associated with the background because, as I said, it's more white. Okay, now as I said, if I say that I want to fix a threshold here, okay, and what I want to get at the end is just an image like this one, but instead of getting gray level image, gray scale image, I want to get a binary image. I want just to get this nice boundary like that, and everything inside of it is in black. Okay, so it's gonna be in black. That is the value 0, and everything here should be white. This is the white. So what I can do is just to define a threshold here and say, well, this thresholded image, this is IT, this is I, this is the image, and this is the thresholded image. So IT, or the thresholded image at a given position, is just gonna be equal to 1 if the image at a given position, or the same position, is higher or equal than this threshold. Okay, so everything here in this range is a background, and everything in this range is an object. So this threshold image should be 0 if the image at a given position is smaller than this threshold. Okay, so this is just how thresholding works. So now let me give you a more formal definition of the threshold, because the one that we just saw here is fixed. Okay, it depends just upon the image. So a more formal definition is, as I said, a function, not a constant. This is more formal, general definition. So the threshold t is a function that depends upon the image itself, because different images would have different values, okay, and as a result, different thresholds. And if the threshold depends only upon the image, it is called global threshold, because we are using that threshold for every pixel in our image. All the pixels in our image are compared to the same value, therefore we say that this threshold is just a global one. The threshold can depend also upon the position of the pixel, xy. In that case, it is called, the threshold of course, it is called adaptive or dynamic. Okay, and another quantity that the threshold can depend on is the property of the neighborhood at a given position. For example, you can take this region here. This is the pixel or the coordinate of the pixel xy I'm considering. So this is xy, and I'm considering the neighborhood here. And what I'm considering in that neighborhood is just some given properties, something like the mean or the standard deviation or any other metric. And this is basically how we do thresholding.